In this lesson, we're going to look at how we can use this Python random mechanics in securing the data. We start with importing two modules. One is OS and another is called secrets. OS is known for miscellaneous operating system interfaces, but we are particularly interested in a function from this module called urandom. It returns a string of random bytes suitable for cryptographic use, and we must specify the size as the parameter. The idea behind it is that returned data should be unpredictable enough for cryptographic applications. So we're calling this function with the size of 10 bytes, and we store the result in, results, and then we print the hex value of each byte. And when we'll run this, we'll see the sequence of random bytes that were chosen. It's a great feature to be used in cryptography, and understanding its potential, a secret module was created and added to this standard library in 2015. So the secrets module is used for generating cryptographically strong random numbers suitable for managing data such as passwords, account authentication, security tokens, and related secrets. So here is a list of traffic lights. It's going to be red, yellow, and green, of course. And we can use another function called the choice from the secrets module, which returns a randomly chosen element from a non-empty sequence, such as the traffic lights. Although it might look like the random choice function, the difference between the random module and the secrets module is that the secrets module provides access to the most secure source of randomness that our operating system can provide. So the secrets module must be preferred for dealing with anything that should remain secret because the random module remains backward compatible. PEP 506 document will contain more information on that. Let me comment out the first print statement and run the code again. As you can see, we picked green, but this time we've done it very securely. But the secrets module also provides functions for generating secure tokens that are suitable for applications such as password resets, hard to guess URLs, and so on and so forth. For example, token bytes function can return a random byte string that contains random sequence of bytes and hexadecimal numbers. So let me comment out the last print statement. We're going to store everything in byte results, and we're going to call secrets.token bytes, and we're going to specify the size, let it be 8. And the only thing left to do is to print the byte results. And let's do another function straight away. This one is called token hex, and it returns a random text string in hexadecimal representation. So it's going to be of a length 8 as well. And let's print the hex results. And when you'll see the output, you might be reminded that these are actually the tokens that you might have seen used by some services or real-life applications. And another function we're going to look at is called token URL save. This function returns a random URL save text string, meaning that this string can be used in URLs. So write URL results secret.token URL save, and we specify the number of bytes, and then we print the URL result. Let's run the code. Because this text is base 64 encoded, on average each byte results in approximately 1.3 characters. So 8 bytes as length don't look too impressive. However, if we'll remove them, it will use some default length. Now it will look pretty impressive. And these are some low-level functions that is good to be aware of them, but not always you're going to use them directly. However, they form a basis for some higher-level functions, and this is where this knowledge comes in handy.